what are we going to talk about? In the beginning, I want to show you why we developed the test set CFD. Then we are going to talk about the innovations and characteristics of the test set. We're going to take a closer look at the individual tests, and we're going to see how the test set scoring looks like and what kind of innovative psychometric options we introduced in here. And in the end, we are going to take a closer look at the main quality criteria of the CFD. So why should there be a new test set for the assessment of dementia? So we decided to develop the test set CFD because in dementia we have some common deficits, like in the intentional functions, and these deficits are better measured with digital test sets because we have here a more precise measurement of aspects like reaction times. We know that most of the elderly people are do not use computers so often, so we decided not to use the mouse for this test set or a response panel, but to use the touchscreen to have a higher usability and a better user experience. Of course, we took account of the current diagnostic criteria for a neurocognitive disorder in the DSM-5. And we also developed parallel test versions so we can have valid follow-up assessments. We conducted age-adequate norming and validation. As you will see later on, we used some very innovative psychometric scoring methods like norm adjustment, which I will show you at the end of this webinar as well. Our aim was to have a reasonable duration time below 50 minutes, especially important for elderly people. And we didn't develop the CFD alone. We had a very renowned scientific partner in the development, who is Dr. Thomas Jahn. He is the Director of Clinical and Experimental Neuropsychology in the Rechts der Isar Hospital, which is a university hospital of the Technical University of Munich. He's also the co-editor of the German Journal of Neuropsychology. He is a member of the German Society of Psychology as well as the German Society of Neuropsychology, and he is a member of the consensus group concerning the S3 guidelines for dementia. So he is an expert in the assessment of dementia, and we used his expertise in the work for the test set CFD. So now let's look at the characteristics and innovations of the test set CFD. Its application area is, of course, the measurement of cognitive impairment as a result of dementia. The target group are people who are suspected of suffering from or diagnosed with dementia from a mild to medium severity. We have two parallel test forms, as I said before. We have a norm sample, which represents our target population from 50 to 49 years old. We have norm samples, of course, for both parallel test forms. The duration is for the standard form around 46 minutes. When you use the add-on test, it's 65 minutes. And currently, the test set is available in German, English, Portuguese, and Italian. So what are the innovations in the test set CFD? We have new possibilities for the test application. You can either use the mouse or response panel or touchscreen as an input mode. We have different kinds of instructions, standard instruction and supervised supported testing. So let's look at the difference of both. So the standard instruction are like in nearly every psychometric test. You have some written instructions on the screen, then there's a training phase for the test person, then there's the test phase. So in the supervisor supported testing, the test supervisor gives the verbal instructions, which are standardized as well in the beginning. Then the supervisor can present the task on his or her own to the client, and then there's the training phase for the test person and the test phase. So the advantage of this is that there's just less written information on the screen, and the presentation phase with the test supervisor enables model-based learning to have a better understanding of the test instructions. So another new possibility are the audio recordings. During the language-related tests, it's able to record the answers of the client or the patient, and you can directly code them for the scoring during the test. testing phase, but you can also just click on them later on and correct your scoring in the result editor. So now let's take a quick look at the dimensions we measure with the CFD. We measure attention, verbal long-term memory, executive functions, expressive language, and perceptual-motor functions. And here we have in most of these dimensions different subdimensions like alertness, divided attention, and processing speed in the attention domain. So now let's take a look at the individual tests of the test set. It begins with the Vienna word fluency test, which measures semantic verbal fluency. The task for the patient is just to name as many animals as possible. Then the next test measures lexical verbal fluency. Here the patient is supposed to say as many words which start with the letter S, so it's lexical verbal fluency. You have 2 minutes time for this. Then there's the learning phase of the auditory word list learning test called AWLT. Here different words are presented, and in a few learning runs the patient is instructed to remember these different words. Afterwards, we have a quite simple paradigm measuring alertness in an intrinsic visual way. Every time the black dot reappears, the task is to push the green button. After this, there's the short-term delayed recall from the auditory word list learning test. So the instruction is here to recall in a free recall as many words which were learned before as possible. Then afterwards we have another test measuring attention, this time divided attention in a cross-model way. So we have two channels, the visual channel and the auditory channel, and the instruction is in the visual channel, if there are two squares after one another, press the green button, and on the auditory channel, if there are two high-pitched tones after one another, press the green button. So here we're measuring divided attention, as you can see. The next test is pretty clear and pretty classic as well. It's a trail making test. Part A, which measures processing speed. Here connect the dots in an uprising format, 1, 2, 3, 4, and so on. Afterwards, part B, which is slightly different, which measures cognitive flexibility. So the patient has to connect the numbers and letters in an uprising way. So 1A, 2B, 3C, and so on. Afterwards, we have the classic Corsi block tapping test, measuring visual spatial working memory. Here, different squares are tipped on by the computer, and the patient has to remember which ones were the selected ones. Afterwards, we have the long-term delayed recall of the AWLT, which is pretty similar to the short-term delayed recall, but it's later on in the testing. Then there's also a recognition phase where different kinds of words are presented, and the patient has to say if he recognizes or she recognizes them or not. After the AWLT, we have the last test of the standard form, which is the Vienna object naming test, pretty straightforward as well. Here we are measuring expressive language, and the client should name the object which is shown. If he or she can't do it or gives a wrong answer on the first try, then there is a lexical hint. So hint 1 would be it starts with B. Then if there's another incorrect or no response, there's a semantic hint. So in this case would be, yes, this is a piece of furniture with a mattress, pillow, and blanket for resting and sleeping. And then we see if the patient gets the right answer. So, as I said, this is the standard form. There are 3 more tests in the long form, which you can use for additional diagnostic information. Let's take a quick look at them as well. First one is a visual construction test where there's a target shape, which you can see on the left side, and the task is to rebuild this target shape with triangles. Then we have another measurement of alertness in an intrinsic and visual way. This is mainly to determine effects of fatigue by comparing the reaction times to the ones from the beginning. And then we have another alertness test, but this one in a phasic cross-model way. So these are all the tests of the CFD. Now let's look at the new innovations in the test set scoring. Here you see the classic table from the test set CFD. Of course, you got all main variables per subdimension presented with percentile ranks or other norm values if you want to. We have dimension-specific indices and also a CFD index for cross-dimensional valuation of the general cognitive impairment. These are based on structural equation modeling, which was performed to evaluate the construct validity. And we also have a traffic light system based on DSM-5. So, which is also new, we have a norm adjustment. This uses regression models to take into account the influence of covariates like age, gender, and the level of education during the scoring. So in this case, raw scores and norm scores are adapted, and this is quite special because here we can take into account multiple covariates, which is not possible when you have the normal norm group samples. So another innovation are the reliable change indices, like you can see right here. You have primary and follow-up assessments jointly presented in the result table. Of course, we advise to use the two parallel forms if we do follow-up or progress testing. And you also have a statistical analysis on an individual level to evaluate whether there was a significant change in cognitive performance or not. These are the so-called reliable change indices. In this case, there was a significant difference. Another new thing, what we have right here is the result editor. As I said, you can do audio recordings for the language-related tests, and here you can do playback and deleting of audio recordings. You can do corrections of the scoring and complement the answer coding. So now we are already at the last point, and now let's take a look at the main quality criteria of the CFD. Let's start with the reliability. As you can see right here, we have the different dimensions, different main variables, and on the right side you have the modern measures of reliability, like the greatest lower bound and the weighted omega. And when you take a look at this table for a second, you see that the reliability in most cases is excellent or good. In some cases it's sufficient. So reliability looks good. Now let's take a look at the validity. And as I said before, we used structural equation modeling on the norm sample 50 plus to see if our data and our test is actually in line with the theory. And as you can see right here, our analysis show factorially structures that are in line with the theory. Our goodness of fit indices like CFE, TLI are quite high. Our badness of fit indices like ARM, SEA, and SRMR are quite low. So our construct validity seems to be good. Of course, we also conducted a study to measure the criterion validity, and we took a look if the tested CFD can reliably discriminate between people who have no disorder, no impairments, and people with MCI or Alzheimer. Of course, we did a parallelization by age, gender, and level of education. So let's take a quick look at the results. Here we see the differences of healthy people and persons with Alzheimer's disease. Healthy sample group is the dark blue, the dementia sample group is the light blue, and as you can see, there are large differences who are also significant in the CFD index and all dimension-specific indices, as well as in all main variables. And now let's take a look at the comparison between healthy people and people with mild cognitive impairment. Here also the healthy sample group has the dark blue, the patients with mild cognitive impairment are in light blue, and as you can see here, both groups differ significantly and with medium to large effect sizes in the CFD index. Now all dimension-specific indices, and you can't see it here, but in our manual as well as in all main variables. Alright, so let's summarize all of this. So the CFD is a digital test set for the assessment of dementia with a focus on early detection. We selected the cognitive dimensions by taking account of the current diagnostic criteria from the DSM-5. We have age-adequate norming from 50 to 94 years. There are a lot of innovations in the test application, like touchscreen testing, supervisor-supported testing, and optional audio recordings. And we also have a lot of innovations in the test set scoring, like the indices on various aggregation levels, the norm adjustment, the automatic scoring, a follow-up assessment, and the evaluation if there has been a significant change with the reliable change indices, and the result editor for subsequent corrections.